Simplify, multiply, and divide expressions. So we're going to work our way into rational expressions. Now, the way you want to think of it, let's break our numbers all into factors. So what do we multiply together to get 8? 2 times 4, 2 times 5. We want to have all prime factors. So see how 4 we can still break down? 2 times 2 times 2 over 2 times 5, because you never know what they might have in common. If everything is being multiplied, you can cancel any common factors, and then we're left with 2 times 2, which is 4, over 5. What multiplies to get 140? If it ends in a 0, we just take 14 times 10 over, if it ends in a 5, we know 5 can go in 21 times, sorry. Okay, now we can break down 14, 2 times 7, and 10 is 2 times 5. Then we can break down 21 into 3 times 7. Now look for any common factors that you can cancel. Anything from the top can cancel anything from the bottom. What are we left with? 2 times 2 is 4, and 3 is left on the bottom. These are considered simplified form because they don't have any common factors. All right, so to simplify rational expressions, you want to factor the top, factor the bottom, cancel any common factors, and whatever you're left with is your answer. Factor, factor, factor. So now we're going to factor expressions, which is the tougher part. So we're going to be factoring a whole bunch more. What's the first rule of factoring? First thing you want to look for, GCF. They each have an X. So pull the X out front. If I divide both of them by X, I'm left with X plus 5. Now we have X squared. Break it into factors, X times X. The whole goal, we want everything to be multiplied. So then any common factor can be simplified. And what you are left with is simplified form. Now, super important. This plus sign connects the X and the 5 together. We cannot cancel if they're not being multiplied. This is connected, so we can't cancel the X. Really, really important. All right, common factors. Factor the top, factor the bottom. There is no common factor, so break it into X and X. Factors of 12, this subtract to get 4. 6 and 2 minus 6 plus 2. Now, this is what we call the difference of two squares, X and X. What makes 4? Plus 2 minus 2. We can only cancel common factors, that which is being multiplied. Final answer, X minus 6 over X plus 2. These have to be exactly the same in order to cancel them. So this is what we're left with. Multiply is just an extension of simplify. So since everything is being multiplied here, technically what we could do, 5 times X times X times Y times 2 times 3 times X times x times x times y times y. Everything is being multiplied. We cannot do this if there is a plus or a minus. All over 2 times x, 3y's. What makes 10? The factors of 10. 2 times 5 times 1. This 2 cancels. This 5 cancels. This y, this y, this y, that x. All right, we have it on the top. There's a 3 and 1, 2, 3, 4 x's. Then we have a 2 and 1 y. So the only reason I can do this, these are all factors because everything's being multiplied. You cannot do this if there are pluses or minuses. Be very careful about that. All right. Common factor. 4x. If I take 4x divided by 4x, I get 1. 4x squared divided by 4x is x. And I'm going to factor the bottom. There's no GCF, so I need 2 parentheses. X and x. Factors of 3 that subtract to get 2. Plus 3 minus 1 times no GCF. X and x. Factors of 6 that subtract to get 1. Plus 3 minus 2. Now 4x is literally 4 times x. I see that 4 is a common factor, so I don't need to break it down anymore. This 4 cancels out this 4. This x cancels out this x. These are being multiplied, that's why I can cancel. X plus 3 cancels x plus 3. Now, what do you notice here? This is 1 minus x. This is x minus 1. When you subtract, do you get the same answer if you change the order? Is 7 minus 2 the same thing as 2 minus 7? No. This side would be a positive 5. This side would be a negative 5. So what I want you to notice, the number part would be the same. It's just the sign that will be different. So anytime you have factors that are the same but the order is different, we can cancel it. We just have to put a negative into the answer. So I'm going to keep that negative 1 times x minus 2. This is the only piece left. When you're multiplying fractions, we're going to put a 1 so that each side has a fraction bar. All right, factoring, this is what we call factoring a cube. And you may have forgotten how to do this from algebra, but what we do, we want to think of everything as to the third power. 8 is 2 to the third, x is x to the third, 1 is 1 to the third. So what we do, is we break our cubes into all perfect cubes. Then we have a little handy dandy phrase that I use. We square the first to get the first, square the last to get the last, multiply them together to get the middle. If this is minus, this is plus, and this is plus. This is what we call a cube. So if you notice, this completely matches this one. We're left with x plus 3 on the top, 2x minus 1 on the bottom. Nothing in common, no common factors. All right, the last couple of pieces are all about division. Do you remember the division rule for fractions? What we're going to do is we're going to change all division of fractions into multiply. What we end up doing, we keep the first fraction the same. We multiply by the reciprocal of the fraction after the divide sign. So all division can be changed into multiplication when we multiply by the reciprocal. All right, so every time you're dividing fractions, your very first step is to rewrite the equation, the expression, using multiplication. The first fraction stays the same. We multiply by the reciprocal. Then this is just like a multiply problem. So we want to break all of our factors down. This is just 5 times x. Those are already in factor form. G, C, F. 3 can go into both. Divide each term by 3. A lot of times I'll just cross out the expression once I factor it so then I know it's not there anymore. G, C, F. There's a common factor of x. Divide each one by x. X minus 2. 2 parentheses. There's no GCF, so I need 2 parentheses. X and x. Factors of 8 that add to get 6. Minus 2, minus 4. All right, now we're ready to get rid of any common factor. X minus 2 cancels. X cancels. X minus 4 cancels. And what are we left with? Five-thirds. All right, example 7. Remember, this is all over 1. So when we rewrite as a multiplication problem, keep the first fraction the same. And we're going to multiply by the reciprocal. All right. So first thing I notice, the easy part, there is a GCF of x. So divide each piece by x. In the top here, this is what you guys always struggle with. If there's a leading coefficient, but there's not a GCF, this is where we need to use 2x times 3x to get 6x squared. Then I need to use 3 and 1. Now, sometimes you can use this to help you out. Look to see if there might be a common factor. Since I have 2x plus 3 on the top, let's try plus 3 minus 1. That gives me 9x minus 2x. All right, so that's not quite right because we need, oh, you know what? This was a plus. I copied this down wrong. So it is right. So this is positive 9 minus 2 is positive 7. So the 2x plus 3 cancels. And there's no common factor left. Be very careful. This x squared and this x are all in the denominator. You can only cancel from top to bottom. So what is left on top? 3x minus 1. Then 6 times x squared times x. 6x to the third. Okay. So first of all, I know that has to go over 1. This is a times, so that means this stays the same, but this is a divide, so I need to change that portion to a multiply. So I'm going to bring down the first fraction. I'm going to keep the multiply, and I'm going to change the divide to multiply by the reciprocal. Then I'm going to, this is the only common factor or piece that we need to factor. There's no common factor. This is the difference of 2 squares. 3x times 3x is 9x squared, plus 5 minus 5. Now we can cancel. Everything's being multiplied. This x plus 5 cancels this x plus 5. 3x minus 5 cancels 3x minus 5. Then x is left on the top. 1 times 3x plus 5 is just 3x plus 5. Now, example 9. What does a fraction bar mean? It's really just a divide sign, isn't it? So what we're going to do is change this divide sign into a multiply. So I'm going to keep my top the same. I'm going to change my divide into multiply by the reciprocal of the bottom. Then I just need to factor, 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 factor. All right, no GCF. So I'm going to want factors of 2 that subtract to get 1, plus 2 minus 1. Now I want factors of 15 that subtract to get 2, plus 5 minus 3. Factors of 40 that add to get 13, plus 5 plus 8. Factors of 14 that subtract to get 5, minus 7 plus 2. Cancel the common factors. Plus 2, x plus 2, x plus 5, x plus 5, and nothing left that's in common. So I just leave x minus 1, x plus 8, x minus 3, x minus 7. Done.